This is the solution to WEX 11.2. Okay, so, well, we'll plot the two intervals. So here's the first one, and the second one. To 20 and 13 to 29. So of all of those, the leftmost number is 2, and it's filled in because it says it's there. So that's 2. Besides 2, the smallest number is 13. It's left open because it's not there. Besides 2 and 13, the least number is 20. It's closed because it's there. So that interval is that. And then 29 is the last number. So like so. So the intersection remember that intersection means and. So it has to be in the first set and the second set. Or if you like, it has to be a red point and a green point. So the 2 is red but not green, and 5 is red but not green, and 27 is green but not red. Only the ones in here are green and red. So we want red. And green. Okay, so between 13 and 20. So 13, 20. Like so. So it says in 3 forms. Well, that's the plot, it's already there. The algebraic notation could be written as 13 less than x less or equal 20, because less than means that open, and less or equal means closed. Then as an interval, that'd be 13 to 20, like so. Find the natural domain of the expression. Okay, so again, we're worried about division by 0. We need to track division by 0, and negative input to even radicals. Well, we've got potentially both, right? There's an even radical, that's square root, and that's there's a denominator there, so we could potentially be dividing by 0. So let's check that. I'll factor this real quick. So that'd be square root of w minus 2 in the numerator. That one's just fine by as it is. Two numbers whose product is negative 48 and whose sum is that? Yes. How about w plus 8 multiplied by w minus 6? Okay. So the numerator it needs to be the case that w minus 2 is greater or equal to 0. That's what's necessary for the numerator. We could express that in interval notation. Well, we need to solve first, right? I guess w greater or equal to 2. So in interval notation, that would be 2 to infinity. So the numerator requires something in that interval. The denominator it's saying that that w can't be -8 and w can't be 6. So we could write that as in interval notation as negative infinity to -8 union -8 to 6 union 6 to infinity. Okay, so we need both of these. So that is to say, we need the numerator condition and the denominator condition. Therefore, it's another intersection. So we want to perform an intersection. So this would be 2 to infinity. And we want to intersect it with 6 to infinity, union -8 to 6, union negative infinity to -8. So the first interval I'll draw here, the second one here. So the points that are of interest, the top interval, it has an interesting point at 2. So I'll draw it just right here in the middle-ish. So 2, and it's saying that we have to be 2 or greater. That's what the first one requires. The second one requires anything whatsoever except -8 and 6. So -8 is back here, 6 is up here, and anything at all is permitted besides those two. In the intersection is when we have both conditions, so red and green. Well, there couldn't be anything back here because none of these are red, so it starts at 2. Then we've got a bunch of points that are red and green, but 6 is not green, so it's not there. So it looks like that. Writing that in interval notation would be, well, I guess I'm going to have to turn a little bit, turn sideways. So writing that in interval notation, that would be 2 to 6 union 6 to infinity. Writing it in algebraic notation, that would be 2 less or equal w, right, because that's what the variable is, less than 6, or 6 less than w less than infinity.